Welcome back to my YouTube channel Learner AK. And today we discuss about a very important topic, selection rules. This is the important topics of PGCM2 friends. If you are new in my YouTube channel, please support my YouTube channel and please subscribe my YouTube channel and share to your friends. Let's discuss about selection rule. Selection rules. Rough dipole moment study. Simply we say rough dipole moment study. Transition probability for absorption, stimulated emission, and spontaneous emission are reduced to the evaluation of transition dipole moment. Mu kn is equal to alpha psi k r vector psi n. This is equation 1 friends, where u is equal to minus e to the power vector r. Transition between all the states are not allowed. The selection rules specify the transitions that may occur on the basis of dipole approximation. Transitions for which the transition dipole moment is non-zero are allowed transitions, and those for which it is zero are forbidden transitions. First point, the transition dipole moment can be considered as a measure of imbalance created in the electromagnetic field when the electron makes a transition between the states. And then the partially of an atom orbital with quantum number L in minus 1L, the rho and d orbital have even partially, whereas p and rho orbitals have odd partially. Next, the partiality of the integrand of transition dipole moment will be finite only when the integrand is totally symmetric under symmetry operation of the systems. And then, therefore, the only allowed electric dipole transitions are those involving a charge in partiality. This is called the Laporte selection rule. For heterogeneous atom, we specify the states by the usual quantum numbers nl and m for a transition to the allowed dipole moment matrix. Element alpha n dash and l dash m dash r vector n l m must be finite on the basis of Laporte selection rule. The matrix element will be finite only when ls minus l is equal to del l is equal to plus minus 1. This is the equation 2 friends. To obtain the selection rule on the quantum number m1, we may write the matrix element alpha n dash l dash m dash r vector m l m is equal to I vector I l alpha n dash l dash m dash u n m plus j vector alpha n dash l dash m dash y n l m plus k n dash l dash m dash z n m. This is the equation 3. If the radiation in plane polarize with the electric field in the z direction, the z component of the dipole moment is the only relevant quantity which are given by alpha n dash l dash m r cos theta n l m. The phi part of this integral 0 integration to 2 pi xpm experimentally I m minus m dash phi d phi is equal to finite. Now friends, only when m dash is equal to m, del m is equal to 0. This is equation 4. The phi part is non-vanishing only when m dash minus m is equal to del m is equal to plus 1. For arbitrary polarization, the general selection rule is del m is equal to 0 I plus minus 1. This is equation 5 friends. Now thus the selection rules for hydrogenic atoms are del L is equal to plus minus 1, del M is equal to 0 plus 1. This is equation 6 friends. The origin of the selection rule del L is equal to plus minus 1 may be linked to the spin angular momentum, which is equal to 1 when a photon is emitted or absorbed. The total angular momentum, the orbital angular momentum of the electron of atom changes by plus minus 1, and absorption or emission of photon may be increase the angular momentum of the electron del L is equal to plus 1 depending on the orientation of the angular momentum of the electron with the angular momentum of the photon. The selection rules discussed so far are valid only the dipole transitions. The magnetic dipole moment of the electromagnetic can interact with magnetic moment of the electron in the atom and induce magnetic dipole transitions. Such transitions are 10 to the power 5 times weaker than those allowed under electric dipole transitions. Now friends, the selection rules for the electric quadrupole transitions are del L is equal to 0 plus 2 and those transitions are 10 to the power 8 times weaker than electric dipole transitions. Thank you friends. This is selection rules. Thank you friends. We meet in next video. Please support my YouTube channel and please subscribe. Thank you.